Good morning, students. Welcome to the experiment number 2 in your digital communication laboratory. The title for this experiment is Efficient Source Encoding via Huffman coding. Let me use the pointer. Yeah, so this is what is the title of your experiment, Efficient Source Encoding via Huffman coding. These are the references. So here I have given the QR codes for the YouTube videos. If you want to learn exactly what is the Huffman coding, anyway, we will be covering the same concept in the class as well. This we had already seen, digital communication system block diagram. This is where the information source is present. That message signal you are transmitting with help of transmitter through channel, and at the receiver we receive it and then decode that information and we get the information back. Now, as you know, in the transmission, the first block which comes into picture is source encoder, and we had seen that the role of the source encoder is to compress the information. So whatever redundancy is present in the message signal, that redundancy will be removed by the source encoder. So we may have the lossless source encoder or lossless source encoder. So in this particular practical, we will be talking about lossless source encoder. Uh, the definition of information is given by this particular formula. So you're having one particular event which is observed by S equal to Sk, and that particular event S equal to Sk has got the probability of Pk. Then the information in that message Sk is given by log 1 upon Pk, where in general K will vary from 0 to K minus 1. And definitely if you take the summation of all the probabilities, that sum should be equal to 1. This ISK, we call it as self-information for the event S equal to Sk. Coming to the concept of entropy, entropy basically gives you the average information content per source symbol. So what is on an average, how much information is being transmitted for individual symbols per symbol. That is what is the meaning of entropy. So in general, for the source S0, we have information IS0, for source S1, IS1 up to I of Sk minus 1, and each of those sources has got the probability P0, P1 up to Pk minus 1. Then we can calculate the entropy for the source by this particular formula. It is expected value of Isk. I hope in your second year mathematics there was a topic on probability, and in that you must have studied what is expected operation. So same expected operation on this information value for all the values of k, that is what you will get the entropy. So when you simplify that formula, this is what is the final formula for the entropy. Summation k from 0 to k minus 1, pk log 1 upon pk base 2. This hs is what we call it as entropy. Source coding, we have discrete memoryless source. We sometimes call it as DMS. It is generating the source symbols SK. And then the source coding, the role of that source encoder is to convert that SK into BK binary sequence. Now here we are having the concept of source coding theorem. So given a discrete memoryless source whose output is denoted by the random variable s, the entropy Hs imposes the following bound on the average code word length L bar for any source encoding scheme. L bar has to be greater than or equal to Hs. So whatever length of the code will be assigned by the source coder, if you take the average length of that code, that average length at the most will be equal to entropy. Most of the times it will be more than entropy. So we are seeing the Shannon's first theorem, where that Shannon has given the limit for the source coding. So here this is what is the limit. The maximum average length of your source code, encoded source code, can be Hs, that is entropy. And then from that we can write the equation for efficiency of coding. So entropy is the maximum possible value and L bar is the average length. So L bar can be at the most equal to Hs, or it will be greater than Hs, and that is why this efficiency ideally should be equal to 1 if that source encoding is done 100% properly, all the redundant values are removed, then the average length of the code will match with that of the entropy. This average length is calculated using this formula. We know the probability for each of the symbol and we know the length for each of the symbol. That is, whatever encoding is done for every symbol, what is the length for that particular encoding, that is Lk. So summation k from 0 to k minus 1 pk into Lk. This is how you will get L bar. Hs, we had already seen the formula for the entropy. Now, actual Huffman coding, the procedure, if you want to use pen and paper and get the Huffman code, then you need to follow those steps. The source symbols are arranged in the order of decreasing probability. So basically, when you want to do Huffman coding, then you will be given how many symbols are there. Say symbol 1, symbol 2, symbol 3, symbol 4, and for each of the symbol, what is the probability of occurrence. That table will be given to you. Once you get that particular table, you need to arrange those symbols in the decreasing order of probability, and then the two lowest probability values are assigned bit 0 and 1. Then combine the last two symbols and move the combined symbols as high as possible. Repeat the above steps until end, and the code for each symbol is found by moving backward. Whatever steps I had written here, I am not explaining you in detail, but whatever two QR codes I had given in the previous slide, if you go through those QR codes, or when we will cover it in the class, you will get the idea how the Huffman coding is actually done by using pen and paper method. So in this practical, you are supposed to follow two steps. First step, you calculate the Huffman codes and code efficiency for given examples using pen and paper. And then you are supposed to write the MATLAB code for the same and verify the efficiency. Of course, you will be able to compare your efficiency, what you get with pen and paper, and with the MATLAB code. That should be matching. So this is the example one. Consider DMS, that is discrete memoryless source, x equal to x1, x2 up to x7. So here there are 7 symbols, x1, x2 and x7, which are generated by the source. And each of those symbols, x1 to xn, it has got the probability pxi, that is 0.4, 0.25, 0.15, 0.1, 0.05, 0.03, 0.02. So if you observe in this particular example already, those probabilities, they are already given in the decreasing order. So they are already arranged. Now, by using the theory for Huffman coding, first using pen and paper, you are supposed to find out the Huffman code for each of the symbols x1 to x7. So that is what is written here. Encode this source with a variable length binary code using Huffman algorithm. Find the source entropy. We have seen the formula for the entropy. Find the average code length. We have seen the formula for the average code length. And find the efficiency from that. We have seen the formula for the efficiency. Similarly, this is example 2. You are given 7 symbols and the probabilities, you need to do same, but only you can observe here the probability values which are given, they are not in the decreasing order. So when you solve this particular example, you will have to rearrange the probabilities and the symbols, and you need to arrange it in the decreasing value of the probability, and then you follow the same steps. Now, when it comes to MATLAB implementation of Huffman coding, the first step is create the Huffman code dictionary. And for that creation of the dictionary, you need to use this particular command, Huffman dict. Now, you're supposed to go through this particular command in the MATLAB help and understand what are the parameters which you need to give as input to this particular command, and what are the possible parameters which you get at the output. Then calculate the source entropy by writing a MATLAB code. We have seen the formula for the entropy. It is a single step formula, same formula you write in MATLAB. Third, note the average code length from the step 1. So when you will be using this particular command for generating the code dictionary, you will be getting the average length. So note down what is that average length which you are getting from this command. Calculate the code efficiency. It is a ratio of two numbers. Create and decode the Huffman code using MATLAB code commands. So here the dictionary is generated. By using this dictionary, you can actually do the encoding using Huffman coding, and then you can do the decoding using Huffman coding. For generation of the sequence of data which you want to encode, you can use the command repmat, that is a repeat matrix. Then whatever code you will generate, whatever sequence of data you will generate, for encoding that sequence of data using Huffman encoding, you can use the command Huffman encode. And similarly, for decoding this encoded information, you can use the command Huffman decode. whatever information you get in encoding and decoding, you know what is the original sequence of data and you know what is the decoded information. You can verify the original data with the decoded data and check whether both the data are identical or not. And for that, you can use the command is equal. So you are supposed to go through the help for each of the commands, understand what are the parameters for that particular command, and then write the MATLAB program. If you have any questions, you are always welcome. Thank you.